आज जल्दी हो गई है. That's cool. So this is the second lecture of rotational motion, and as I discussed in last class also, that we are going to discuss moment of inertia and theorems in this lecture. So I'll try my best to cover these two topics here. But first, let's start with the recap of the previous class. Can you help me with that?
Yes, ma'am.
So please continue.
Rigid body,
Okay. What do you mean by
types
rigid
of
body?
motion. The distance in between two initial particle won't change.
Yes, when no matter how much force you are applied, no matter at what degree you are applying it, but there would be no change in the internal distance between 2 points. So that type of body is called rigid body. It's a ideal concept, right?
Yes, ma'am.
Cool. After it,
Types
let's move
of
to the next
motion.
topic.
Types of
Types of
motion.
motion. Very nice. Types of motion. Okay, can you explain me the rotational motion? Because that is important for me now. Anyone?
Ma'am, the type of motion where every particle revolves around a fixed point.
Very nice. Can you tell me a very specific, very beautiful thing about rotational motion, which I told you as the hashtag of it?
Rotational motion is the collection of circular motion.
Yeah, these hearts for you, Miss Pat. Thank you so much. I really want you guys to, tell me that particular line. And okay, so
Thank you, ma'am.
you, yeah. So rotational motion, I told you always remember it as a collection of circular motion. So very nice, very nice. Okay, when I like your definition also, it's just that okay, I want this one. Okay. Now, after rotational motion, can somebody explain me the planar motion? Anyone?
The sum of rotational motion and transition.
Very nice. Very, very beautiful. She said. Uh, एक second, beta. So, Namrata said, planar motion is translational motion added with
Rotational
rotational.
motion.
Exactly. Very nice. Although we are not going to deal much about planar motion, it's a rotational motion that I'm more concerned about. But it's nice to know कि we have the idea of planar motion. हम जानते हैं planar motion क्या है. Let's move towards the another one.
Analogy.
Yes, we have discussed the analogy. This is very important because here you connect linear variables with angular variables, and it will help you a lot. So, what is S omega? And sorry, no, S. I don't know what is happening right now.
V.
Wait a second. Wait a second. My screen got stuck. Just give me a second. Okay, so let me write it here. S V A. These are the basic ones. Now tell me, what is the analogy of S in angular terms?
Theta.
Theta.
Very nice. What about V?
Omega.
Omega.
Beautiful. What about A?
Alpha. Alpha.
Alpha.
Cool. Can you tell me the relations also? Hmm? Like, how can you connect S and theta together?
Because of analogy.
No, no, no. Like that, no? Angle, arc, radius. Angle. So angle is equals to arc by radius now. So from there you can get S is equals to r theta, B is equals to r omega, A is equals to r alpha. You We'll get this by angle is equals to arc by radius, and these two can be the like you can get them by differentiations with respect to time. Yeah, cool. So you should remember this slide. Should we need to add in any other topic, or is it? Well, is it okay? बस इतना ही करना था हमने.
Okay, ma'am.
Okay, I think I have discussed about the torque.
Yes, ma'am.
Yeah. So can you tell me about torque?
Amount of turning.
Very nice. किसने बताया?
मैम ने.
Very good, Manish. I told you that torque is amount of turning. Very nice. And I think I gave you an expression also now for this.
Yes, ma'am.
Okay, what it would be?
R into F.
It is torque, since it's a vector quantity. So it is R
R
cross
into-
F. Basically the cross product. Okay.
Yes, ma'am.
Yeah. When you expand it, you will get RF sine theta. So make sure that you remember it like that. Now, on the basis of this expression, I can tell you the amount of turning will depend on three factors. It will depend upon R, it will depend upon the force, and it will depend on the angle at which you are applying it. Yes or no?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay. Do you know how to calculate the direction of torque vector on the basis of this cross product? Or basically, I should ask you like this key. Do you know how to find the direction of the cross product? Do we know that? Anyone?
No, ma'am.
Okay. So let me tell you. Let's say I have a vector A here and a vector B like this. Okay. This is the angle in between them, theta. Now I want you to calculate A cross B. Okay. But in the terms of direction only. I want direction. Where your C vector would lie.
In
Now,
between A and B.
no. See, I told you, na, this thing. Let's say vector C is the resultant of A cross B, then vector C is perpendicular to vector A as well as it is perpendicular to vector B. So basically, the vector C is supposed to lie in the a plane which is perpendicular to the plane of the plane of vector A and B. For an example, A and B lie into this plane. Then this C vector cannot be lie in the same plane with these two vectors. It has to be in the perpendicular one. For an example, let's say this is the x-axis, this is the y-axis. The cross product of these two axes would be z-axis. Okay? And it is perpendicular to both y and x. Is that okay?
Yes, ma'am.
Yes, ma'am.
Okay. Now, let me tell you a trick how to find out the direction of vector C, because it is very important. Okay? We should know about it. So whenever you have this kind of scenario ki A cross B gives you C vector, so take your right hand and be very specific about the hand. You can only use your right hand. So take your right hand and arrange your fingers in the direction of first vector. By first vector, I mean this one. Okay? Whatever it would be. So in this case, this is the A vector. So place your fingers in the direction of A vector. Can someone open the camera, switch on the camera, because I am not able to do that. Can you do that? Anyone? No? Okay, so let me try. If I find issue in the audio or video something, then I will switch it off again, because there is some network issue in my area right now. Okay? So let me
Yes,
try.
ma'am.
Oh, wait a second. Hmm. एक minute. एक minute. Yeah. ठीक है. So, if you find difficulty in the video or audio or anything, if screen lagging is going to happen, then let me know. ठीक है, I'll switch it off again because it will take a bit more data and video is on. So let's start with this trick. It is a very beautiful trick and you should know about it. So whenever you have two vectors here, for example, I have A cross B. So whatever the vector you have at the first place, keep your fingers of right hand in the direction of that. For example, A vector is lying like this now. दिख रहा है ना screen पे A vector is like this. So put your
Yes, ma'am.
fingers like this. See? दिख रहा है, हाथ चला गया filter में. Okay. Put your fingers like this, vector A. And now curl your fingers from vector A to vector B, like this. Okay? Curl your fingers from vector A to vector B. So wherever your thumb will point out, that is the direction of vector C. Is that okay?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Pakka? Cool. So that's how we basically find out. इसी को बोलते हैं right hand rule. Right hand thumb rule. Although we have a screw rule also, but I'm not a fan of it. ठीक है, because sometimes it's hard to imagine कि भाई how the screw is going in or it is coming out, but this finger is nice because it is very easy na. Just place your finger in the direction of first vector, curl it from first to second, and your thumb will pointing out towards the vector C. And you know that is the reason why A cross B is not equals to B cross A. A cross B is not equals to B cross A. Why? Because now B is at the first place. So arrange your fingers in the direction of B and curl it in the direction of A. Now thumb is pointing towards, into the plane. Initially it is coming outward, out from the plane. Now it is inward into the plane. So basically the direction is opposite, and if two vectors have different direction, then they cannot be equal. That's why A cross B is not equals to B cross A. Is that fine?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, then let's start with a question. ठीक है, let me draw a pendulum. ठीक है, this is a pendulum. A small mass M is hanging by a thread. This is let's say 1 meter long. ठीक है, I deviated it to a 30-degree angle like this. This is the same pendulum, right? I just draw it with a different color to let you know कि भाई हमने 30 degree जो है इसको move करा दिया. We displace this bob by 30 degree. Is that okay?
Yes, ma'am.
Yes, ma'am.
Okay. So the question is, find the torque due to all forces that are acting on the bob. ठीक है? So basically, I guess you can understand that there are two forces which are going to play their role in this case. First is the force due to gravity, which you know as weight, and the other one would be tension, which is due to the string. So basically, you need to find out the torque because of tension and because of weight. Is that okay?
Yes.
And the question says that M is equals to 1 kg. Okay, just solve it out. It's 18:04 right now. You have 2 minutes to solve this question. Then I will, overtake this class. Hanji, so have you got the answer?
Ma'am, is it 5?
For which force? See, whenever you're talking about torque now, you have to be very specific about the force, because on a even on the same body in the same scenario, due to different forces, the torque can be different. Is that okay, Ashta?
Yes, ma'am.
Okay, so you're telling me 5 about which force? Yeah, for which force? No? Take it.
Ma'am, force acting on the bob.
Due to meaning. Like I told you, na, ki here we have two type of forces. Let me draw them. One is this mg, and the other one would be tension. So you're telling me, ki, ma'am, it's 5. So which force? Is it weight or is it tension? That is my question.
Wait,
Okay,
ma'am.
okay. Second. Is it? It's absolutely correct. What about the tension?
Tension 1.
Okay, कोई नहीं. Let me take the question
Ma'am,
from
little
here.
confused.
Okay, कोई नहीं. I'll take care. देखो, this is the final position of block, right? They gave you this angle as 30 degree. Now draw the forces over here. ठीक है? I always said कि भाई mg will always work towards the center. No matter whether your mass is at inclined plane, it is a declined plane, whatever the situation would be, the force due to gravity will always act towards the center of the earth, right? Now just break the components. So if you will do that, throw a Cartesian coordinate system over here basically. So this angle would be 30 degree, right?
Yes, ma'am.
Yes, ma'am.
Wait a second. This is mg now. So we will get, yes, that angle would be 30 degree. So basically you will get mg cos 30 degree like this and mg sin 30 degree like this. Okay. Now, let's break the components for tension also. Tension into this string would be like this. This angle would be theta or 30 degree. So it would become T cos 30 degree. And oh, you don't need to break the components here. And let me tell you the reason why. See, this is a very beautiful question. Why? Tension is lying along the radius now, along the axis. I told you now about axis in the last class. Can tension provide rotation over here? Can it turn the block or this bob? It will not. Because tension is along the principal axis.
Ma'am, you are not audible.
Am I not audible?
You are audible, ma'am.
Because today I will take this thing, there is a issue in the network. So if I'm not audible, so yeah, I can switch off the camera. Just let me know. But now I guess everyone is saying I'm audible, right?
Yes, ma'am.
Yes. तो एक बार देख लो बच्चा. Maybe it is network issue at your end also. You can refresh it and rejoin. I'm saying this tension is along the principal, so not the principal axis, along the axis of rotation. So in that case, the theta would be 0 or 180 degree now. And at sine 0 or sine 180 degree, it is going to be 0. So basically torque is 0. If torque is 0, the amount of turning is 0. And that's how you can tell me कि ma'am tension cannot produce any kind of torque, or the torque due to tension would be 0 Newton meter. Is that fine?
Yes, ma'am.
Similarly, when it comes to mg, the mg cos 30 degree will not produce torque because again it is also along the axis of rotation. The only component of force mg sin theta, this one, it will provide you the torque because it is perpendicular, right? So when you want to calculate the torque due to mg, you will write r cross but basically rf sine theta. So sine theta here, theta is, देखो ये complicated है. Theta is
30
an
degree.
angle. क्या हुआ बेटा?
Nothing, ma'am.
Okay. Theta is an angle between R and F. ठीक है? And that angle is 90 degree. That's why I'm gonna write R cross F. But make sure that only mg sine 30 degrees producing the torque. So this sine 30 degrees is due to the force, not because of this sine theta. Okay. Now you can write the value R into m into 10 into sine theta is 1/2. It would become 5 Newton meter. Is that fine?
Yes, ma'am.
Pakka?
Yes, ma'am.
Very nice.
Actually, in case of force, why there you took mg sine 30 degree?
Because mg is at some angle. I need to resolve into vectors. Either it is lying along the that axis of rotation along that length, so then it would be okay because I can simply take it as 0. But it is at some angle, so that's why I need to break it into either direction, either along that length or perpendicular to it. That's why I do this. So perpendicular will
My
take.
answer is correct, but in case of force, I only took 1 into 10, and in case of theta, I took sine 30 degree.
So basically it's a fluke which comes into a fall into a place, but that is not the right way to do it. You need to understand one thing, that mg cos 30 degree and t, they are lying along the length, and if they are lying along the length, then the angle between r vector and f vector would be either it would be 0 degree or it would be 180 degree, and sine 0 sine 180 is 0, so there will be no torque.
Yes,
Okay.
ma'am.
I told you this thing in the last class also, that only the perpendicular component of the force or perpendicular component, basically perpendicular what, radius or the length, whatever you have, the perpendicular to that, only that component can produce the torque, or the amount of turning can come through that particular component basically. Let's come to the next question. It will help you to understand how to deal with the cross product. So basically, wait a second. I have a force 2 I cap 3 j cap minus k cap. ठीक है? Now they said कि a force or this F is applying on a point P. ठीक है? We have a point P and we don't have point P. Basically, we have a coordinate for point P, and that is 1, 2, 2. ठीक है? So at this point P, this much amount of force is acting on. So you need to find out the torque. You need to
Ma'am,
find out
can
the
you
torque
repeat the
at
question?
point. Yeah, I will. You need to find out the torque at point P due to F. This is your question. Okay? Question says कि we have a force and they give you the force 2i cap plus 3j cap minus k cap. They gave you the coordinate of a point P, which is 1, 2, 2, and they said find the torque at point P due to F. Is that okay?
Yes, ma'am. Yes, ma'am.
Okay. So, आया आंसर? Is it
Yes, ma'am.
difficult?
Yes, ma'am.
बताओ क्या आया?
18 under root 5.
हाँ?
Ma'am,
क्या
just a
मतलब
number.
है? Okay. Should I try?
Yes, ma'am.
Okay. See, in this question, you have only the coordinate of P. Whenever you get this kind of scenario, always try to do try to introduce an origin. ठीक है ना? Because you have a force in the vector form. So in order to get torque, you also need R in the vector form. है ना? Only then na, you can find out कि R cross F is torque, right? So at least you need a R vector, right? Right.
Yes, ma'am.
Cool. So if I consider this origin, I have a point P. Now I can have R vector now. I think you have dealt these kind of questions in mathematics in class 10th, that x2 coordinate geometry, x2 minus x1,
Yes,
y2
ma'am.
minus y. Yes. So it would become 1 minus 0 I cap and 2 minus 0 j cap and 2 minus 0 k cap. Right? So it would become I cap, 2 j cap, 2 k cap. Now you have a R vector also. Whenever you got this, when you got this R vector, F vector, now you need to calculate the torque. Torque is R cross F. Okay? So you need to write it like this: I cap, j cap, k cap. This is first now R vector. So write the coefficients of I cap under this I cap column, right? So here it would be 1, it would be 2, it would be 2. When it comes to force, write 2 here, 3 here, minus 1 here. Do you have any doubt in this thing?
No, ma'am.
Pakka? नहीं है ना?
Yes, ma'am.
ठीक है. You got this R cross F. Now write here I cap. When you write I cap, just eliminate the row and the column which contains I cap, which means you need to eliminate this row and this column. Okay, just do a cross product over here. It would become minus 2, minus 6, right? Write minus of j cap. You are supposed to write minus j cap always. Always minus j cap. This is the rule to solve this determinant. Okay. So in that case, you need to eliminate this j cap wala row and the column, right?
Ma'am, it's coming under root 90, but I couldn't find the factors for it.
Okay, koi issue nahi. That's very cool. You are doing it. Now eliminate the row and the column of which contains j cap. Okay, and then again do the cross multiplication. Here it would become minus 1 and it would become minus 4. Right? Write down plus k cap. When you are dealing with plus k cap, what are you going to do? When we are dealing with plus k cap, what we will do? Bolo, 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 bolo.
Sorry, will you repeat your question?
I said, when I'm going to write the, the form for k cap, what I'm supposed to do?
You are going to eliminate k column.
Very nice. The row of k cap and the column of k cap. And then do the cross product. So 3 into 1 would become 3 minus 2 into 2 would become 4. Now just solve it. It is your torque. So torque would become minus 2 minus 6 is minus 8 I cap. Minus 1 minus 4 is minus 5. It would become plus 5 j cap. 3 minus 4 is minus 1 and it would become minus k cap. So this is your torque. If they are asking you about the magnitude, then you can calculate it by, doing this thing. Minus 8 square plus 5 ka square plus minus 1 ka square. You will solve it and you will get the answer. I think
Ma'am,
8
is it
square would
3
become
under root
60.
10?
Kya beta?
Is it 3 under root 10?
Let me solve it. 64 plus 25, 459, 9, 1, 10, 1 carry, 6 to 8, 1, 9, 90. Right?
I have
Right,
did
right,
10
right.
into 9, so under root 3.
Acha, yeah, it's 3 root 10, yeah. Newton meter. This is the amount and this is the vector form. Is that okay?
Yes, ma'am.
Yes,
Okay.
ma'am.
Let's come to the another topic, which is moment of inertia. It is very important. Okay? It is very, very, very important for this particular topic. Moment of inertia is basically it concerned about two things. The first question is uh, actually I used to teach it in Hindi, so it was like कितना मास है और कहाँ पर है. ठीक है? It was like what is the amount of what is the amount and where it is located basically. So basically it is connected about the mass and the position. Okay? And that's why you basically have inertia as mr square. M is the mass, R is the position. Is that okay?
Yes,
Yes,
ma'am.
ma'am.
So when I said na ki kahan, this where, so basically you need to answer from axis of rotation. Ki it is situated at R1 or R2, but from where? From axis of rotation. So for example, I have a system of particles over here, and let's say this is the axis of rotation. Okay? One particle is at this position, R1. It is at R1, right? R1 distance. This one is at R2 distance. Let's say this one is at R3 distance. Let's say this one is at R4 distance. And let's say this one is at R5 distance. Okay. Now it is okay. It is okay in the terms of the where they are located. But what about the mass? So you would say, ki, ma'am, this is M1. It is located at R1 distance from the axis of rotation. It is M4, which is located at R4 distance from axis of rotation. It is M2, which is located at R2 position from axis of rotation. It will not make any difference either it is on the left side or in the right side of the axis of rotation. I just need to know ki what is the particular distance, right, from the axis of rotation. So basically, this kind of data you can give me when it comes to discrete system of particles. Is that okay?
Ma'am,
Yes,
will you
ma'am.
repeat once?
Which portion basically? Hmm?
Ma'am, what you told in short, can you repeat the concept?
Okay. I just said ki you need to know about two things whenever you're talking about the inertia, and that two things are the amount of mass. So what is the amount? And where is it located from the axis of rotation? Okay, I need to know these two things in order to calculate the inertia, moment of inertia. Is that fine?
Yes, ma'am.
Yes, ma'am.
Cool. Okay. So
So
your
can you show
formula would,
previous slide?
wait a second. Your formula would be like this. You need to just sum up the entire expression in this manner. Okay. There could be number of particles, and you can write them like this, where I can run from 1 to n. Is that okay?
Yes, ma'am.
Yes,
Its
ma'am.
unit is kilogram second square. Take. And this is the when I tell you the analogy of linear variable and circular or angular variable, I told you that inertia, moment of inertia, is the analogy of mass. So basically, you will have, for example, I have F is equals to ma in linear terms, right? When it comes to angular variable, you can write torque is equals to I alpha, because this F is the analogy of torque, the analogy of m is inertia, and the analogy of a is alpha. Is that okay?
Yes, ma'am.
Cool.
Yes, ma'am.
Now you can write down this slide also, and then I will move towards the next one. Let me know once you've completed it. ठीक है. Now, now what? Let's talk about an important topic, and that is static equilibrium. ठीक है? Static equilibrium. Here we have two terms, right? Two words, static and equilibrium. Let's understand them one by one. Static means at rest, and equilibrium means a state of balance, right? Right?
Yes, ma'am. Yes, ma'am.
ठीक है. Wait a second. Now, whenever you have a static equilibrium in rotational chapter or in the terms of rotation, you will have basically two types of equilibrium. ठीक है? One is called translational equilibrium. Translational equilibrium. And the other one would be rotational. Rotational equilibrium. When it comes to translational equilibrium, you can write this equation that sum of all the forces, or you can write the net force is zero. And if you have this privilege that net force is zero, you can basically write that acceleration of center of mass is going to be zero, or you can write the velocity of center of mass would be constant. Is that okay?
Yes,
Huh?
ma'am.
Yes, ma'am.
When it comes to rotational equilibriums, see, in the same manner, in the terms of linear variables, you can write it also. You can write it as k by torque is going to be zero. The net torque is zero. But when it comes to the torque now, so we supposed to be very specific about the point. About which point? I said torque is zero, but about which point? So the question is about any point. The answer is about any point, the net torque is zero. So that point is something which you can choose by your own ease. ठीक है? अपनी ease के हिसाब से we are going to choose that point. It could be anyone. It could be center of mass. It could be at in the in between or at end of the body. It could be anywhere. You can select it as per your own terms. Is that fine?
Yes, ma'am.
Yes, ma'am.
So I can write it here. Right here. If net torque is zero, then alpha is zero. If alpha is zero, so you can say, I would like to do it here. Yeah. So you can say कि omega of that point or any other point is going to be constant basically, right? Quite similar.
Yes, ma'am.
So I said कि whenever you will discuss about the net torque, you will always discuss about the point. So about any point, ठीक है? um, I should use wisely. Why wisely? For an example, let me just discuss a case for an instance. Let's say um, this is a rigid support or a rough surface basically. This is also a rough surface. Okay? I put a ladder over here like this. Okay? It is your wall, it is your surface basically. So now you can see mg is lying along this position, right? Normal reaction would be like this. Let's say ki I said ki bhai, just to make a clear instance, let's say this is a smooth wall. Okay? It is a smooth wall. So this is the normal reaction which this wall would give you. But now let's say due to this mg, this force is flipping down. So this point A will move in this direction and this point B will move in this direction. Yes or no?
Yes, ma'am.
Now this point A is moving since this is the smooth wall, so there will be no friction. But when it comes to floor, you will get a friction. If you are moving towards this direction, you will get a friction like this. Okay, so basically here I have 3 points. If you can see them, here I have 3 points. One is point A, another is this one, and another one is this B. So what point should I set ki bhai about this point I will take ki torque is 0, because I have a privilege now, I can select anyone. So about which point I should consider this condition? About A, B or C? C is this point. A is this one. B is here.
Point B.
And why, Miswa? Why should I go with point P?
Because
Any,
this is not the,
Miswa, please tell me once again.
because यहाँ पे distance बहुत कम है.
किससे? नहीं. See, as I said, you need to make a wise decision. So by that I mean you need to select a point where you will have a maximum number of forces. Because if I said कि भाई उन forces की वजह से torque 0 हो जाएगा. अगर just listen to me. Here I have only one force at point A. At point C, I have only one force, but at point B, I have two forces. If I write here torque at B is 0, so basically what I'm saying that torque due to normal reaction N is 0, torque due to friction is 0. So I just eliminate the torque due to two forces. So this is a wise decision, and this is a nice reason to select this point P. Yes or no?
Yes, ma'am.
Okay. So that's it. Let's do a question then, and we will end our class by that question. Okay? Let's say this is a fixed support, and from this support we have two strings. We hang two strings like this and like this. Okay? There we will have a rod like this, a block like this, and then I placed a smaller block here. Okay? Are you getting the diagram?
Yes, ma'am.
Okay. So the question said this is 100 centimeter. Okay? This is the center point, and they said that this block is at 40 centimeter from the one end of the body. Okay? This block. Now they said कि small m This is of 5 kg. Okay? This block is of 10 kg. This is tension T1, and let's say this is tension T2. Point T1 and T2 if the system is in a static equilibrium. Is that okay?
Ma'am, that above 100 centimeter, what you have written, that 4 centimeter or 40 it is.
40. It is 40 centimeter.
Ma'am, it is the
Okay.
distance from center or beside the tube.
It is the distance between the center of this yellow block and with the end of this rod. Okay.
Okay, ma'am.
And you can consider कि these these strings now, these are applying at the end of the body. Okay. I should draw it like that actually. Let me draw it like that. You can say कि this is going like this and this is going like this. Okay. इस तरीके से है. Now find the T1 and T2. And question has said कि भाई tension static equilibrium is there. It is 1840 right now. You will have 3 minutes to solve this question. Then I will help you. And remember one thing, while you are calculating the torque, you need to find out ki in which direction that torque is applying. Okay? In which direction that torque is going to produce the turning. So if if some forces are producing torque in clockwise direction, you can consider them positive. And if there are and some of rest of the forces are trying to turn that body in the anti-clockwise direction, you need to consider them negative. Okay? So make sure कि you will consider the direction of torque as positive and negative since it's a vector quantity. Is that fine?
Yes, ma'am. Yes, ma'am.
Have you solved it? Huh? Hello. Am I audible?
Solving, ma'am.
Yes,
Okay.
ma'am.
Time is up. Let me do that. Okay. Let's consider this is at point A, this is at point B, this is point C, and this one is point D. Let's draw the forces, right? At point A, you will have a tension T1 in this direction, and at point B, the mass of the bigger block is in this direction. At point C, you will have the mass of a smaller block, and at point D, you will have a tension like this. Yes or no?
Yes, ma'am.
Take care.
Yes, ma'am.
They said that system is in equilibrium. If system is in static equilibrium, then basically I have translational equilibrium as well, right? And as well as rotational one. So if I have translational equilibrium, so basically sigma f is 0 in every direction. So in x also 0, in y also 0. So I can consider here sigma fy because I have the forces in y direction. So you can write कि ma'am t1 plus t2 since they are in plus y is equals to capital M plus small m into g since these are in the negative y. Is that okay? Hmm?
Yes, ma'am.
Okay, just wait a minute. Take care. Fine. Now they said ki capital M and plus M is basically 10 plus 5, which is going to be 150 Newton. So this is your first equation. The T1 plus T2 is equals to 150 Newton. Now let's come to the another part of this static equilibrium, which is rotational. In that part, let's solve it. So you need to find out ki which force is trying to do what. Now I have basically a task to perform that what is the value of T1 and T2. I have already that T1 plus T2 is equals to 150 Newton from this translational equilibrium. So is it fine now? I find some T1 or T2. What will I do? Either I can put torque at A0 or torque at D0 because in both these conditions, T1 and T2 could be 0, right? So either you can take A or B. I will take A, you can take B, and that will be fine. I said torque about A is 0. Now this capital mg and this small mg, they are trying to move this rod in this direction, which is anti-clockwise. Sorry, clockwise. And this T2 will try to move this block in this direction, which is your anti-clockwise. So as per notion, you should take it as positive and this one as negative. But even if you don't follow this notion, you will obviously take them in opposite manner. You know? It will going to be the same, but still let's follow the notion. So take anti-clockwise direction as positive and clockwise as negative. This is quite weird because normally you do the opposite to it. But okay, let's solve it. So due to this capital, okay. Now I'm concluding everything about this point A. So you need to find out the force of the distance of every force from this point A. This capital mg would be at 50 centimeter, right? And this block C or this point C will be at 60 centimeter from point A, and this T2 will be at 100 centimeters. Is that okay?
Yes, ma'am.
Okay.
Yes, ma'am.
So you have to do only one thing: minus capital MG multiplied by 50 minus small mg multiplied by 60 plus T2 multiplied by 100 is equals to 0. R cross F. ठीक है ना? Just solve it. So you will get T2 into 100 is equals to capital M plus small m is 50, no, again 150, ठीक है, into 50 into 60, right?
Yes, ma'am.
If I took basically just solve this equation, ठीक है, just solve this equation. I guess ये ऐसे ही आएगा. If I took 10 into 10, it would become 5,000, and this would become 50 into 65 is 63, right? 3,000. Is it okay?
Yes, ma'am.
It would become 8,000. And from here you can T2 as 80 Newton. See, you get the value of T2. You have this equation that T1 plus T2 is 150 Newton. Just put T1 as 150 minus 80 and you will get 70 Newton, right? So basically your answer would be 70 comma 80 Newtons. Is that fine?
Yes, ma'am.
Yes, ma'am.
So basically that point about which you are taking torque 0, it matters a lot to make that choice wisely. And in the next class, we will have next class on Tuesday, right? In next class, we will discuss about theorems, okay? And we will do few numericals to wrap this chapter up. Thank you so much for being so nice. It really means a lot. Have a nice time ahead.
Thank you, ma'am.
Thank you, ma'am.
Thank
Welcome
you,
back.
ma'am.
Bye, ma'am.
Bye bye.
Thank you, ma'am.
Welcome. Welcome. Welcome, Harshda. Bye bye. Welcome, Irfan. Bye.